Hello, friends. We are now on week 13 and we are doing Khan Academy Unit 14. This is a really big unit. And so, in order for us to finish it this month, we're going to need to do 10 squares a week, which is actually a lot more than what we've done before. But what's nice about doing a lot more work is that there is a lot more leeway as well. So, just the way that we do points in our class. So let's get to these videos and figuring out how to do Khan Academy Unit 14. Okay, so parabolas. All right, let's see. I'm going to be toggling back and forth between having the whiteboard out and not. All right, graph a parabola whose x-intercepts are at x equals -3 and x equals 5, and whose minimum value is y equals -4. Okay, so I'm just going to drag this to 5, and then this is going to have to be right there, right? So let's see, -4. So I've got the minimum value at y equals -4. I've got x equals +5 and x equals -3. So this is really visual, really easy, super, super easy. So I hope they're all like this. What is the x coordinate of the parabola's vertex? Okay, let's see. Parabola intersects the x-axis at x equals 3 and x equals 9. Okay, we are going to need a hint for this and take a little bit of notes. So hang on just a minute. Okay, I'm back. So all we want to do is we want to find the midpoint between 3 and 9. So if we have any kind of parabola, that axis of symmetry, that x value, it's just going to be the midpoint between those 2 points. So right now, we have 3, x equals 3, and x equals 9. So if we just take the bigger number minus the smaller number, so 9 minus 3 equals 6, and then that will give us the midpoint. So the x coordinate of the parabola's vertex is going to be equal to 6. Okay. Okay, which parabolas open up? B opens up and C opens up. Very easy to do. Okay, so let's go on the next question. Graph a parabola whose vertex is at 3, 5. So x equals 3, y equals 5, with a y-intercept at y equals 1. So let's see, y equals 1 is here, and it could be here or here depending. Vertex is at 3, 5. Y-intercept at y equals 1. Oh, y-intercept. Okay. So yes, this y-intercept is going to intersect that y-axis. So there we go. There's our parabola. Pretty easy. Okay, so now we've had some experience with parabolas visually. So that's really great. All right, next square. Let's go. Leah took her friends for a ride in her hot air balloon. The function f models the height of the hot air balloon above the ground in meters as a function of time in minutes after takeoff. Plot the point on the graph of f that corresponds to when the hot air balloon landed. That's pretty easy, right? Because this is the hot air balloon over time, and then it lands, right? So that's pretty easy right there. All right. Sophie opens a new restaurant. The function of f models the restaurant's net worth in thousands of dollars as a function of time after Sophie opens it. Plot the point on the graph of f that corresponds to the restaurant's minimum net worth. So at a minimum, sorry, my voice kind of cracked there. At a minimum, the minimally, right, the restaurant was at negative $12,000 at one point. So that would be the minimum. Let's see if we're correct. All right. Biologists discovered an invasive bird species on an island. The function f models the population size in hundreds of birds for this species as a function of time after being discovered. Plot the point on the graph of f that corresponds to the number of birds in the population when the biologists discovered it. Okay, let's see. When they discovered the island. Okay, let's see. I'm trying to think of when that would be. After being discovered. So, were they discovered here? Time zero? I think time zero would be when the biologists discovered it, right? Because then it was an invasive bird species. They discovered this invasive bird species, and then maybe they did something to decrease the population of the birds. So it would increase for a while, and then, whatever they did worked, and so then their population decreased. So I'm guessing that it's at time zero, which is the y-intercept. So let's see if I'm right. Yep, that's it. All right. Mia kicked a football. Function F models the height of the ball above the ground in meters as a function of time after Mia kicked it. Plot the point on the graph that F corresponds to when the ball hit the ground. Again, just like the hot air balloon example, it's going to be that x-intercept, but not the first one. That's when she kicked it. And then the second one is when it lands. So let's see. Some visual parabola stuff. So pretty easy so far. All right, let's go to the next one. Interpret a quadratic graph. Sarah kicked a ball in the air. The function f models the height of the ball in meters as a function of time in seconds after Sarah kicked it. Which of these statements are true? Okay, the ball reached its highest point after about 3.5 seconds. So here's 3.5 seconds, but that is not the highest height. So not right. The ball reached its highest point after about 14 seconds. Well, 14 seconds is way over here. So that wouldn't be right. The ball moved downwards until about 1.5 seconds. Well, it's going to move upwards until about 1.5 seconds, right? So 1.75. 1.5 would be here. Yeah. And then it starts moving downward at 1.7. Well, yeah, 1.75. Yeah, about that. The ball moved downwards after 1.75 seconds. Yes, exactly. So choose all the answers that apply. I really think it's only D. Let's check. All right. Sometimes, when you're doing these problems, you'll read something and you'll miss something, or so it's pretty common to miss one, especially when it's not just one answer that it could be many. So you've got to go through all of the options and make sure that they don't work. Okay. Simon has a certain length of fencing to enclose a rectangular area. The function A models the rectangle's area in square meters as a function of its width in meters. Okay, so let's see. Choose all answers that apply. Greater width always relates to smaller area. Not true, because we have, this one's the width and then this one's the area. So I could have a width of 8, width of 10 would give me an area of 100, while a width of 4 gives me 70. So that's greater width, but a bigger area. So that would not be correct. Greater width relates to smaller area as long as the width is less than 10 meters. So that's not true either, because let's see, because on this side of the graph, greater width relates to greater area, and on this side of the graph, greater width leads to smaller area. So that one's not right. When there is no width, zero width, the area is 20 square meters. Well, that's not really true either. Well, it's true according to, let's see, when there is no width. Oh, no width is here. When there's no width, the area is 20 square meters. No, that's not true, because when there's 20 width, the area is 0, theoretically, right? When there is no width, okay, that's this point right here, the area is 0 meters squared. Yes, that's the only one that I can see that is true. Because when there's 20, when the area is 20, let's see, this is the area. When the area is 20, then the width is going to be like 1. Yeah, about 1. So that's not true. All right, so I think that's it. Great. Which of these oh, we got to read the problem. The function G models the number of mosquitoes in millions of mosquitoes in a certain area as a function of rainfall in that area. Okay, that makes sense, because the more rainfall you get, the more mosquitoes you get, and then the more you keep going on, and pretty soon, if you get more rainfall, then you'll get less mosquitoes, because I guess too much rain kills the mosquitoes. Like a little bit of rain will make them multiply, and then too much will kill them all. Essentially, maybe. I don't. Someone that's a biology expert, if you're studying biology, you might be able to see if that's really true. But that's the function that we're trying to explain here. Okay. A, the largest possible number of mosquitoes when rainfall. There's the largest possible number of mosquitoes when the rainfall is about 2 centimeters. So rainfall is 2 centimeters, largest amount. Yes, that's true. Oh man, excuse me. I'm kind of fighting off a cold here, so hopefully I can make it through. There's the largest possible number of mosquitoes when rainfall is about 4 centimeters. Okay, so when rainfall is 4 centimeters, it's actually the least possible number of mosquitoes. So that's not true. There are no mosquitoes when there's no rainfall. In our graph, that is true. That may not be true in a practical standpoint, but according to our graph, that is true. So you have to think about this mathematically and not too practically, if that makes sense. Because I'm sure in the jungle, if there's no rainfall that day, then there's probably mosquitoes because there was rainfall before. But this is theoretical, of course. Right? Is there any place on earth that gets absolutely 0 rainfall, in a year? I'm not really sure, but possible. I don't know. Okay. But we're thinking mathematically here. That's what is designated. If there was a theoretical world where there was absolutely no rainfall ever, there would be no mosquitoes. There are no mosquitoes when rainfall is 4 centimeters. So rainfall is 4 centimeters again, and there's no mosquito. Right? Okay. So, check. So that one was crazy because there were actually 3 of those that were correct. So you've really got to read through all of the choices and make sure that you're choosing the right combination. Okay. A certain company's main source of income is a mobile app. The function H models the company's annual profit in millions of dollars as a function of the price they charge for the app in dollars. And remember, in any company, there can be a negative net worth where the company is losing money. So these negative values can be applied practically. Okay. So, but again, we're thinking of this in a mathematical standpoint where things can be theoretical. Okay, the company's profit will be 0 if they don't charge for it. Okay, so let's see, app price. Okay, so here is the app price. And if the company does not charge for this app, man, sorry guys. Okay. If the company does not charge for the app, that's 0 right here. This is the y-intercept. Maybe the company had to pay some developers to develop the app. And so they're going to be actually out of $10 million. So they're going to be in the hole $10 million if they don't charge for this app. Okay. So that is not true because the profit is not 0. It's negative 10 million. Okay. The company's profit will be 0 if they charge about $1 or about $13 for it. Okay, so let's see, about $1, then the company's profit's going to be 0. And then also if they charge about 13, so that one's right? I know that's kind of not exactly 1 and not exactly 13, but it does say about 1 or about 13. If you think about it, there's going to be a lot of people that pay for the app. We're thinking theoretically, right? So there's going to be a lot of people that can pay for the app if it's only $1. And so they're going to be paying off those developers and not making any money. Likewise, if they charge too much for the app, about $13, how many people are actually going to buy it? Not very many. And so they're not going to make any money there. They're just going to make just enough to pay off the developers for developing the app. Okay. Greater app price relates to smaller profit. Greater app price relates to smaller profit. Okay, so that's this side of the graph where we charge more for the app and we're actually going to get less profit for it because we're charging too much. There's not going to be that many people willing to pay that much for the kind of app that we are developing. Okay. Greater app price relates to smaller profit as long as the app's price is less than about $7. So that's less than $7 is this side of the graph. So that one's not true because greater app price results in greater profit if we charge $7 or less. Okay. Greater app price relates to smaller profit as long as the app's price is more than about $7. And that's true. If the app price is more than $7, then the more we charge for it, the less profit we're going to make. Okay, so it's just those two. All right, fun, right? We're just looking at graphs and interpreting them. Pretty fun. We haven't really done any number crunching, but sometimes part of math is just looking at things and trying to interpret them. But it looks like we're going to start doing some math. Yay. Okay. Solve for x, enter the solutions from least to greatest. Okay, perfect. Okay. So we actually get to solve for x now. Yay. Here we go. Okay. So we're going to take this part. So I have something here, 3x minus 6 times something equals 0. So if that something were, so if I can set any of these equal to 0, anything times 0 will equal 0. So I can just take apart these equations and I can have 3x minus 6 equals 0. And I can have negative x plus 3 equal 0. So I can take this apart because I have this part times 0, that would equal 0. And then I have 0 times the second part equals 0, that would equal 0 as well. So this is how we solve. Okay, so now we're just going to solve for x. Super easy, right? 3x equals 6, x equals 2, and then we have negative x equals negative 3, x equals 3. Okay, so the lesser x is 2. I'm going to input 2 here. And then the greater x is 3. So we are doing some math here. It's not too bad, right? Okay, let's go ahead and see if we are correct. Here we go. Next question. Okay, so same thing. We have x minus 5 and 5x plus 2. And we're finding the zeros, right? So we're actually finding those x intercepts where y is equal to 0. So we're setting this equation equal to 0. F of x is y. So we plug in 0 for y and we solve for x. Okay? So then we have x minus 5 equals 0. And then we have 5x plus 2 equals 0. So x minus 5 equals 0. X equals positive 5, right? 5 minus 5 equals 0. So 5x equals 2. X equals 2 fifths. Okay, and you don't have to change a fraction to decimal. That's just fine. So our lesser x is 2 fifths because 2 fifths is less than 5. 2 fifths, and then we have 5 here. Okay, let's see if we are correct. Oh, not correct. Let me see. Enter the solutions from least to greatest. Okay. Okay, who caught my mistake? This is -2. If you move a positive over, it's negative. So that was my mistake there. Okay, so same thing. We're solving for x and finding the zeros. We have 2x minus 1 equals 0, and then x plus 4 equals 0. So we have 2x equals 1, x equals 1/2, x equals -4. So which one is the lesser x is going to be -4. And then the greater x is 1/2. Okay, let's see if we are right. No negative mistakes there. Those negatives, they get you every time in algebra. Okay, -5x minus 1 equals 0, and 2x plus 8 equals 0. So we have -5x equals 1, x equals, right? We have to divide by -5. So we have to divide by that negative. So it's -1/5. Over here, we're going to have 2x equals -8, not making that negative mistake again. And then x equals -8 divided by 2 is -4. Okay, so which one is the lesser x? So in negative numbers, remember, just to review, -1/5 is here, but -4 is over there. So the lesser x is actually -4. Remember, if I owe my friend -1/5 dollars, that's a lot less than, that's not as, that's not as deep in the hole as owing them -4. So anyway, lesser x is -4, then the greater x is going to be -1/5. Okay, let's see if we were right. Did it make any mistakes? All right, there we go. All right, again, I have orange. That's going to be fixed when I take that. I'm not going to take it, but you guys will. Don't worry about the oranges too much. That will be fixed when you take the unit test at the end. They will turn to purples and crowns and all that stuff. So unless you need to review. Okay, now we are graphing the equation. So first we're going to find our zeros, and our zeros are going to be those x-intercepts, where we set y equal to 0 and we figure out where we can graph those x-intercepts on there. Okay, so let's go ahead and plug this in. Okay, so we have x plus 6 equals 0, and then we have x plus 4 equals 0. Okay, so x equals -6 and x equals -4. So let's see, x equals -6. Okay, -4. Okay, so I mean that's going to be, so I can tell it's positive, so it's going to open upward. Okay, and actually I'm going to move this over here to -6, and my x, I'm going to move me up here so I can graph this. So I know that this is going to be right in between those my x-intercept. So I have an x-intercept at -6 and an x-intercept at -4. But I don't know what my y value is. So I like to just plug it in to the equation. This is really the simplest way to do it. So I'm going to go ahead and write my entire equation. Y equals 4, x plus 6, and then x plus 4. And I know the x value is -5 because that is right in between my two zeros. So I'm just going to plug in -5 to my x's, and I'm going to see what I get for y. So here we go. Y equals 4, and then I'm going to plug in my -5 plus 6 and my -5 plus 4. Okay, so that's how you do it. So we have -5 plus 6, that is 1. So 4 times 1 times -5 plus 4 is -1. So I have 4 times 1, which is 4, times a -1, which is -4. So I have y equals -4. So I have when x equals -5, y equals -4. So let's see if we are correct. Here we go. Okay, so that's how you do these. Pretty simple. Just there are some steps to these equations. So don't forget to just follow the steps and just be patient. You know, there is some number crunching here. It's not just visual anymore. Okay, so let's go ahead and take our pieces. We're going to set them equal to 0 to find our zeros. Okay, to find the x-intercepts. So step 1 is always find the zeros or the x-intercepts. Okay, so we have x plus 5 equals 0, and then I have x minus 3 equals 0. I don't really know why I wrote parentheses there, but let's just go ahead and erase those for now. Oh, there we go. All right, so we're good there. Okay, so I can tell x equals -5 here, and then x equals +3 here. So I'm just going to graph one of those x-intercepts, and I'm going to go ahead and graph the positive one, +3. And then I know that my other one is -5. So I'm just going to move this to where I see that the 0 is hitting that -5. Okay, so I know my value is going to be -1 because that is the midpoint. And I just don't know where it is. I see that it's negative, so I know it's going to be pointing downward. So I know this y value is going to be positive because that's where the parabola points downward. Okay. But to find the actual value, we just need to plug in this -1. Okay. Here we go. Y equals, we're just writing the equation. And sometimes the hardest part of this is copying down the right equation. Sometimes if you make a negative mistake, here or there, you write a negative as positive and then solve it. Your answer is wrong, right? So this is algebra. You have to be really, really particular and careful. Okay, so I'm going to plug in -1 for my x value. -3/8 times -1 plus 5, and then -1 minus 3. Okay, so I have y equals -3/8. And then I have a value of -1 plus 5 is going to be +4. And then I have -1 minus 3, which is -4. Okay, so I can rewrite this 8 as 2 times 4. So that's going to cross out I can cross out one of those 4s. And then I can rewrite this -4 as -2 times +2. So I have a +2 down here, and I can cancel out those 2's. So now all I have are whole numbers. Yay, because I hate dealing with fractions, right? So I have -3 times -2, which is a positive value. So negative 3 times negative 2 is going to be positive 6. Okay. So let's go ahead and graph this. I'm looking for positive 6, and I still have my zeros at negative 5 and positive 3. So let's see if we are correct. Yeah. Okay, these are fun, right? Okay. First step is to do the zeros. X equals, oh, whoops. X minus 1 equals 0. X minus 9 equals 0. X equals 1. X equals 9. Okay, I just need to find the midpoint. So I'm going to graph X equals 9. And then this is a positive function, right? I don't have a negative right here. So I know it's going to be opening upward. And X equals 1. So I want to move this over so that my 0 moves over to 1. So now I know my X value for my vertex is 5. So now I'm just going to rewrite my function. 3/8 times X minus 1 times X minus 9. Okay, now I'm going to plug in positive 5. Okay, here we go. F of X, or you could write Y, whatever. They mean the same thing. 5 minus 1 and 5 minus 9. Okay, so I have 3/8. Write F of X again. 5 minus 1 is 4. Easy peasy. And 5 minus 9 is negative 4. Okay, so I can rewrite this 8 as 2 times 4, cancel out one of the 4s. I can rewrite this negative 4 as negative 2 times 2, cancel out one of those 2s. And now I'm just left with 3 times negative 2, which is negative 6. And that makes sense that I got a negative value because I want the parabola to open upward. And now I'm just going to graph negative 6. And that is correct. Let's see. All right. Do easy peasy. Okay. So don't let this different format scare you a little bit. It's the same thing. We're just going to find our zeros. So I have X minus 2 equals 0. And then I have X equals 0. Easy peasy. So X equals 2 here. So I have positive 2 and 0. So I'm going to go ahead and move it to 2. And then I'm going to move this over so that my second 0, my graph is intersecting with that x-axis at 0. Okay, so I'm going to plug in 1. But I notice that I have a negative here. So I know my parabola is going to open downward. So I know I'm going to get a positive value when I plug in this 1 into my equation. So I'm going to rewrite the equation. G of x, remember G of x, f of x, we just decided to call this graph G. We decided to call the graph F last time. One time we decided to call it Y. It means the same thing, equals negative 6, x minus 2, and then x. So now we're going to plug in positive 1 for x and see what we get for y. Negative 6 times positive 1 minus 2, and then positive 1. All right, so I have g of x equals negative 6 times 1 minus 2 is negative 1, and then positive 1. So I have negative 6 times negative 1 equals positive 6 times 1 equals positive 6. Okay, so let's go ahead and graph that part. And we are there. So super easy. Well, not super easy. There were more steps to that one. Okay, so now all we're doing is we're finding the zeros. And it's just, instead of just getting a random function for no reason, we actually have a word problem associated with it. No big deal. You can read the problem. I'm just going to take the easy way out, and I'm just know that which app prices result in $0 annual profit. I'm looking for those zeros. That's all I'm going to do. So I'm going to take this piece, x minus 3 equals 0, and then x minus 11 equals 0. I'm going to solve for x, right? You don't even have to write this down here. You could look at this. Okay, x minus 3. What's going to make that 0 when x equals 3, right? When x equals 11, right? So what's the lower price? This 3. What's the higher price? 11, right? Super simple, super easy. No big deal. Don't let the word problem scare you. It's going to be okay. Okay, so same thing. So, oh, not the same thing. Let's see what we're looking for. Now I'm going to read because I'm not really sure. The ball's height in meters above the ground, x seconds after a meter through it is modeled by this. Okay. How many seconds after being thrown will the ball reach its maximum height? Okay. So we're looking for maximum height. So this one I can't do in my head. I'm going to use my handy dandy whiteboard here, and I'm going to do it over here. So I do need to find the zeros first. So we do x plus 1 equals 0, and x minus 7 equals 0. Okay, perfect. So I know that x equals -1 and x equals +7. Okay, so what I'm looking for is I'm looking for that maximum height because I have a parabola going like this, and I need to find that x value. But if I realize that this is -1 and this is 7, I just need to find the midpoint. So all I do is I take 1x and I subtract it from the other. So midpoint, right, equals 7 minus a -1, right? I think. No, I don't think that's going to work. Divided by 2. Divided by 2. Yes, this is going to work. Okay, so 7 minus a -1 is the same thing as 7 plus 1. That's 8. 8 divided by 2 equals 4. Okay, so does that make sense? If this is 4. So I have 1, 2, 3 on this side, and I have, let's see, okay, when we want to find the midpoint, we need to add the two numbers. So we're going to have 7 plus -1 divided by 2. So 7 plus -1 equals 6. Same thing as 7 minus 1 divided by 2. That equals 3. So 3 should be the midpoint here. And that makes sense because this is 1, 2, 3. That's 4 counts in that way. And this 4 counts in that direction. So the midpoint is 3. So it's going to be 3. Okay, let's see. Yes. Okay. Maximum height. Again, I'm looking for that midpoint again. Let's go ahead and clear our board. We need to find the zeros first. So x equals -1 and x equals +7. Oh, this is the same one. Okay. I don't know why I didn't. We want to find the y value now. Okay, so we know what our zeros are. We found the midpoint to be equal to, so midpoint, we found the midpoint to be equal to x equals 3. Now we're going to find the y value, associate that to find out how high the ball got. Okay, so we have -x plus 1 and then x minus 7. We're going to plug in that +3. H of x equals -3 plus 1. And then we have 3 minus 7. So then we have h of x equals -3 3 plus 1 is 4. And then 3 minus 7 is negative 4. And then we have a negative times a negative equals a positive. And that makes sense, right? Because if he's throwing a ball, it's going to reach a positive height and not a negative, right? So, and then we have 16. Okay, so 16 meters. Okay, let's see if we are correct. All right, new question. Okay, what do we want? What is the height? Okay, so remember, we have to find the zeros, we have to find the midpoint, and then we have to find the height. Those are the steps. Let's do this. Here we go. X plus 1 equals 0. X minus 3 equals 0. X equals negative 1. X equals positive 3. So to find the midpoint, we're going to add them and divide by 2. Negative 1 plus 3 divided by 2 equals negative 1 plus 3 is 2. 2 divided by 2 is 1. 1. All right, so now we're going to write down our function. H of x equals negative 5 times x plus 1, x minus 3. We're going to plug it in 1. H of x equals negative 5 plus, not plus, plug in 1. 1 plus 1 and 1 minus 3. All right, so then h of x equals negative 5. 1 plus 1 is 2. 1 minus 3 is negative 2. All right, so we have negative times a negative is a positive. 5 times 2 is 10. 10 times 2 is 20. So we're looking at 20 meters. What is the height of Anna above the water at the time of diving? This is right? Her height in meters above the water, X seconds after diving, modeled by this. I think this is right. I'm pretty sure this is right. Let's plug it in, and then let's see if we're right. No. Okay, I'm not thinking about this right. So let's go ahead and kind of graph this so we're kind of... She is going to dive, let's see. We have negative 1 here. We have positive 3 here. So here is her thing. We found the maximum height, and we found, if I just would have sketched the graph, it's always good to sketch the graph. If I would have just sketched it, then I would have understood what they were talking about. They wanted the y-intercept. Where is the graph equal to where if I plug in 0 for x, what do I get for y? Right? Is that what they're asking? Yes. So now we actually didn't have to do any of this. That didn't really help us with this question. But what does help us is I'm going to take this part and I want to find what h of 0 is. If x equals 0, what is y? Or what is h? Okay, negative 5. I'm going to plug in 0 for x. 0 plus 1 is 1. Then I'm going to plug in 0 for x here. 0 minus 3 is negative 3. Okay, so what's my height? Negative times a negative is a positive. That makes sense. 5 times 1 is 5 times 3 is 15. It's 15. Okay, so sketch the graph, read the problem. Don't make these same mistakes. All right, great. So again, I got one of those wrong and I get an orange square. No biggie. I know that once I take the test and I get those answers right, they will turn to purples and crowns and I will be just fine. Okay, so we've done 5 and we have more to go. So we have to finish 10 this week. So make sure you schedule enough time in your week this week to get this all done, because it is a lot of problems and we are working hard here. Okay, solve for x. Enter the solutions from least to greatest. Okay, so now we're just adding that extra step. Now the problem is not factored for us. We're actually going to have to factor first, and then we're going to have to, and then we'll solve. Okay, so let's dive in. And the title is Quadratics by Taking Square Roots. Okay, so we're actually going to take some square roots. So if I'm trying to see what I want to do here. Okay, so because we have an x squared here, we don't have any x's, we don't need to factor. We don't need to do that foiling factoring stuff. So we're actually going to just combine, we're going to isolate this x squared variable, and then we're going to take the square root. So let's write down our first problem. Negative 2x squared minus 9 equals negative 107. So I'm going to go ahead and add 9, right? Because we want to isolate x squared. So I have negative 2x squared equals, let's see, if I add 7, then that gives me negative 100. But then I have 2 more, so that's negative 98. And then I need to divide by negative 2. So I have x squared equals a negative divided by negative is a positive. 98 is even. So if it were 90 and if I divide by 2, that gives me 45. Then I have 8 left over. 8 divided by 2 is 4. So 45 add 4 is 49. Another way you could do that, I think my mom likes to do, like 98 is close to 100. So 100 divided by 2 would be 50, but then you have to subtract 1, right? If I take 100 divided by 2, it gives me 50 each. But then I have to take 1 from both sides. So that gives me 49. So different ways to think about it, mental math. All right. So now we're going to take the square root of both sides. So square root, we have this square root of x squared is just x, right? Super simple. And then I have to do plus and minus when I take the square root. 49 is a square. The square root of 49 is 7. So then I have 2 solutions. I have x equals positive 7, and I can write x equals negative 7. Another way that we like to write this in math is I can also just write a comma, and I can write negative 7. So when you're writing it on your paper, I know a lot of you write it on your paper when we do Khan Academy, right? But I'm just giving you some about how we write math, right? Okay. So you can write it like this to show that there are 2 solutions, or you can write it like this to show there's 2 solutions, positive 7 and negative 7, positive 7 and negative 7. 2 ways of doing it. Also, x equals positive 7, x equals negative 7. This one works as well. So there's 3 ways to show mathematically there are 2 solutions for x for this example. All right, the lesser x is negative 7. The greater x is positive 7. And let's see if we are right. Yay. Okay, let's do this one. These are fun, right? So if you do not have your squares memorized, it might be nice to just go through and make a cheat sheet where you have 1 squared equals 1, 2 squared equals 4. So you're writing down all of the squares. That's if you don't have it memorized. So I highly recommend making yourself a cheat sheet if you do not have those squares memorized. We have 5x squared minus 20. And find the zeros of the function. So we're looking for those zeros. So we're going to set it equal to 0. Okay. And notice I only have one x squared. Because I only have one x squared, I don't have another x. I can always isolate the x squared variable. I don't have to FOIL or factor because I only have one variable. Very simple. Okay, so I have x squared equals 20. I can, 5x squared equals 20. Now I can divide by 5. X squared equals 20. Divide by 5, which is 4. I notice that 4 is a square. I can take the square root of both sides. And I have x equals plus and minus 2. Okay, square root of 4 is 2, right? But I have to take the positive and the negative side. So the lesser x is going to be negative 2, and the greater x is going to be 2. All right, let's see if that's what we want. All right, these are fun, right? 2x squared minus 5 equals 13. 2x squared. I'm going to add 5 to both sides. 13 plus 5 is 18. Now I'm going to divide by 2. X squared equals 9. 9 is a square. Square root. X equals plus and minus 3. The lesser x is going to be negative 3, and the greater x is going to be 3. Okay. It's nice that they have nice numbers. Everything's worked out kind of nicely. They're kind of weaning us on to the bigger, more difficult problems. They are coming. All right, here we go. F of x equals 8x squared minus 800. Oh, we're finding the zeros, right? So you can just set this equal to 0. And then I have 8x squared equals 800. And then I have 8. I'm going to divide by 8 both sides. So 800 divided by 8 is 100. I notice that 100 is a square. Square root both sides. I have x equals plus minus 10. The lesser x is going to be negative 10. And the greater x is going to be, did I write 20? It's going to be 10. Okay. And that's it for that square. I'm sure the bigger, harder problems are coming. Let's see what's here. Okay. We need to solve for x, and we're going to enter our solutions from least to greatest. Perfect. Okay. So things are looking a little bit more complicated. Don't worry, I still see only one x. And it's really not that bad yet. Okay. I'm still looking for the zeros because I'm solving for x. Okay. So I have x plus 1 quantity squared minus 36 equals 0. So I can add that 36 over. X plus 1 squared equals 36. I noticed that 36 is a square. It's just something to notice. It doesn't make our steps any different, but something to notice. I can square root both sides from here because I have a square here and a square here. X plus 1 squared, square rooted, is x plus 1. And then plus and minus 6. So I need to split this up into 2 pieces because I have x plus 1 equals positive 6 and I have x plus 1 equals negative 6. Let's go ahead and write those equations separately. X plus 1 equals positive 6. X plus 1 equals negative 6. I have x equals 5 and I have x equals negative 7. So my lesser x is negative 7 and my greater x is 5. So in the previous square, things worked out a little bit nicer. that we had a positive value and a negative value of the same value. But now we have this piece where we have this extra step of having two equations and solving for both equations. So a little bit more complicated, not so bad yet. Yes, the scarier questions are coming, but we're not there yet. This is good. Okay. So find the zeros of the function. I have x plus 8 squared minus 1 equals 0. And then I'm going to add 1. So I can isolate the squared portion so I can square root both sides. X plus 8 squared equals 1. Notice that 1 is a square. So I can take the square root of both sides. And I have x plus 8 equals plus and minus 1. I split that into two equations where I have x plus 8 equals positive 1 and x plus 8 equals negative 1. And then I have x equals negative 7, right? Because 1 minus 8 is negative 7. And then I have x equals negative 1 minus 8 is negative 9. So my lesser x is the one that's deeper in the hole, which is negative 9. And then negative 7. Okay. Let's check that. All right. Looks good. So these aren't so bad once you get used to them, right? You just, part of math is really about practice. Again, we're just looking for zeros here. So I have that x plus 7 squared. I'm going to add over the 11. Notice that 11 is not a square. Remember, it doesn't change how our steps or anything. We're just noticing these things so that we can prepare ourselves for how we're going to handle it. Okay, so I'm going to square root both sides. And then I have x plus 7 equals plus and minus. Now, before we had these perfect squares that we could square root them and they would simplify to a whole number. That was kind of nice. But now the square root 11 doesn't simplify nicely. So 11 doesn't have any factors. I can't, like if it were 8, right? 8 is not a square, but it has a factor that's a square. So I could split that up. If it were a square root of 8, I could split that up into the square root of 4 and the square root of 2. And the square root of 4 is 2, so then I have 2 root 2. Right? Do you remember when we were doing that before? But with the square root 11, 11 is prime. So I can't really simplify it. So I'm just preparing my brain for how I'm going to handle this, right? So I can't simplify the square root of 11, right? All that to say. So I'm just going to write square root 11, right? Plus and minus square root 11. Pretty simple. Now I'm going to do what I did before. Remember, my steps remain the same. So don't get scared off by something looking or being different. Our steps remain the same. We're just handling it. We're just noticing things to handle them a little bit differently. So I have two equations. I have x plus 7 equals positive root 11. Okay. And then I have x plus 7 equals negative root 11. Yeah, not too bad. So I have x equals negative 7 plus root 11. And then I have x equals negative 7 minus root 11. And those are two answers. So which one is the lesser one? Well, on the first one, I have, can I change colors here? Color red. Okay, I have negative 7, and then I'm adding something, right? And then here I have negative 7, and I'm subtracting something. So when I subtract something, it's going to be lesser. So this one is my lesser one, if that makes sense. So minus 7 minus, now the square root symbol, I forget the keyboard shortcut. Oh, round to 2 decimal places. So it wants us to use the calculator. All right, so let's go through this. Show calculator. So I'm going to turn to black again. Okay, so I'm going to do negative, let's see if I can put my cursor here. -7 minus, now I have a root somewhere on here. Root right here. Root SQRT. 11. Oh, put my cursor back. 11. Close my parentheses. Hit enter. And it gives me a crazy scary number. X equals -10. And I'm going to round to 2 decimal places. 0.31. I look at the neighbor. The neighbor is bigger than 5. So I'm going to round up to 0.32. Okay, now I have to enter, so I'm going to clear, and I'm going to do -7 plus, and you can type this in SQRT, parenthesis, 11, parenthesis, hit enter, and I have -3 point, now it wants 6, right? That doesn't change. Now 8. So I look at 8's neighbor, which is a 3. 3 is less than 5, so I keep 8. Okay. So remember how I said this one was the lower one, the second one? Because I have -7 and then I take something away from it. Here it's really easy to see. Owing your friend $10 versus owing your friend $3 is worse. So that's definitely the lesser one. Okay, so let's go ahead, punch in our numbers and see if this is right. -10.32, and we have -3.68. Now, these are a lot of numbers, and there's a lot of places to go wrong here. So this is right. And hey, we got it right. So a little bit more complicated, a lot more steps. We can do this. All right, let's look at this problem and see what we've got here. Okay, we have x plus 5 quantity squared minus 64 equals 0. All right, so first step is to isolate the squared portion, which in this case is x plus 5. So I'm going to add 64 over. So I have x plus 5 squared equals 64. I'm going to square root both sides. Is 64 a square? 64. I don't know why. I just can't think today. You can always do. Here's the shortcut. If you haven't memorized your squares, SQRT, parentheses, 64. What do we get? Yes, it's 8. Okay. So now I have 2 problems now, right? I have x plus 5 equals positive 8. And then I have x plus 5 equals -8. X equals -5 plus 8 is 3. And I have a -8 minus 5, which is -13. Is that right? Doing math on camera is always a little bit weird, hard. Okay, if I take -8, I subtract 2, that's -10, and then I have 3 left over, so -13. Yes, I feel confident with that answer. Okay, the lesser x is going to be -13, and then the greater x is positive 3. Are we correct? Yes. Okay, so on my Khan Academy, I only had one of those hairy numbers where it didn't work out to a perfect square. On your experience, Khan randomizes their questions. So your experience may be different. You might get 3 of those hairy questions. And if they're, it's just practice in dealing with not nice numbers. And so if that's the case, make sure you come to my office hour, come see me. We can do some problems together and we can get it figured out. All right. We have 3 more squares to go. Let's do this. Okay. TJ solved a quadratic equation. You know what? Side note here, I really hate these because I can second guess myself so many times when I'm looking for a mistake. So these problems are so hard for me. Are they hard for you? How do you feel? Or do you like these because things are done? You just have to check and see what's right. I don't know. They're difficult for me. Let's see what we need to do. His work is shown below. With step 3 missing, what could TJ have written as the result from step 3? Okay, this isn't too bad. This isn't finding the mistake because sometimes I'm like, what's the mistake? Okay, I know, side note there. Okay, well, from step 2, all I need to do is square root both sides, right? So what is the square root of 25? That is a square, right? So I would have square rooted, so I wouldn't have the square root anymore, but I would have square rooted everything. And so the square root would have gone away, and I would have had plus minus 5 because the square root of 25 is 5. So it's B. Okay, not too bad. Okay, Meredith solved a quadratic equation. Her work is shown below. In which step did Meredith make an error? Sorry, guys. I'm fighting off the cold. I'm trying my best here. Okay. These are the ones I don't like because I'm like, where's the mistake? I'm not really sure. Okay. 242 divided by 2 is 121. That's what she got. Square root of 121 is 11. Oh, but that's where she made the mistake, right? So it should have been plus minus 11 here. So in my mind, step 2 is the mistake because she should have written plus minus 11 because there are 2 answers when we square root both sides. Step number 2. Yay. Okay, Eliza solved a quadratic equation. Step 2 is missing. Okay, what should she have done with step 2? Well, before we square root both sides, we really need to get rid of this fraction. And the way to get rid of the fraction is to multiply by the reciprocal, right? The reciprocal of 1/5 is actually positive 5. So I'm going to multiply this side by 5 and then the other side by 5. So that's what I need to do. So I would have the fraction go away, and then 5 times 20 is actually 100, which is a square. Makes it nice. Okay, so I'm looking for 100 here, and I'm looking for this fraction to be missing. So which one is it? It looks like it's this one. Not too tricky. Okay, where did they make an error? Okay, again, I don't know. Okay, we can do this. Plus 3, that 29 plus 3 would be 32. So we're good there. Now we need to multiply by the reciprocal of 1/2, which is 2. 32 times 2 would be 64. Oh, she didn't write 64. She actually divided by 2, which would not be correct. So she made her mistake in step 2. All right, we made it through. We made it through looking at those mistakes. Yay. Okay, next square. All right, create a list of steps in order that will solve the following equation. Okay, so the first thing I would add 1 to both sides. Okay, do I need to move them? Yep, I need to move them over here. All right, add 1 to both sides. You want? I cannot do this in my head. You guys with the young brains can probably do this in your head. I have an old brain and I cannot. So 1/4 x plus, oh no, sometimes I have a button on this pen here and sometimes I press it and it makes things all wonky. So let's try this again. X plus 5 squared minus 1 equals 3. So I'm going to add 1 to both sides, and then I get 1/4 x plus 5 squared equals plus 1 plus 1, 4. Okay, now I need to multiply by the reciprocal of this fraction, right? I need to go like this, times 4, and then times 4. That's what I need to do. So I need to multiply both sides by 4. And then this fraction goes away, and I just have x plus 5 squared equals 4 times 4 is 16. Super simple. Okay, now I'm going to take the square root of both sides. So that's what I need to do here. Take the square root of both sides. So square root square root, and I have x plus 5 equals plus and minus 4. Because 16 is a square. Yay! No nasty step there. We're good. Okay, so what am I going to do now? Now I'm going to split the equation into two equations. So what do they call that? I call it split the equation, but I'm sure they don't say that. What do we say? Our options are to add 1 to both sides. Nope. Multiply. Nope. Multiply. Nope. Subtract 1. Nope. Subtract 5. So I think they skipped the split the equations. I like to split the equations. X plus 5 equals positive 4. X plus 5 equals negative 4. And in both of those steps, I do need to subtract 5 from both sides. So I have x. So I'm going to do that one. That one looks good. Subtract 5 from both sides. Yeah. Okay. 4 minus 5 is negative 1. And then negative 4 minus 5 is negative 9. Okay. There we go. So, like I said, we didn't need to know the answer. We just needed to know the steps. And some of you can do this in your head. And for me, I just have an old brain. Okay. I could try to do this one in my head. Let's try it and see how it goes. First, I'm going to add 5 to both sides, okay? And then I'm going to divide by 2, right? Because I don't have a fraction here. I have a whole number, so I need to divide both sides by 2. Divide both sides by 2. Okay, now I'm going to take the square root of both sides. So that's what I'm going to do next. And then it's going to leave me with that. X plus 2 equals plus minus something. So now I need to subtract 2 from both sides. So we're subtract 2 from both sides. And that should give me my answer. Okay, I did it. Okay, again, steps. Create a list of steps. Okay, we're going to subtract 2 by both sides. Subtract 2 from both sides. And then I'm going to multiply by the reciprocal, which means I'm going to multiply by 2. Multiply both sides by 2. And now I can take the square root of both sides. And now I can take that, subtract 5 from both sides. Subtract 5. Okay, I'm getting this. My brain's working. Okay. You can totally do this without showing your work. Let's see. What am I going to do first? Well, actually the step of adding or subtracting something from both sides is done, right? We're kind of skipped at that step. So my next step here into isolating the squared portion of the equation is I just need to divide by 3. So divide both sides by 3. And then I'm going to go ahead and take the square root of both sides. And then I'm going to subtract by 6. So that one had less steps, right? One of was already done for us. Right. This is our last square for the week. So this, not too bad. This is going to be fine. Oh, we're just graphing the function. I know when I say that, we're just graphing the function. So our first step is we need to find the zeros. I know, you guys. I know. These, we're getting to the portion. I'm going to put my video somewhere where it's not in the way. We're getting to the portion in algebra where there's actually a lot of steps to complete. So you might be looking at a problem and say, I don't even know what the first step is. So if that's the case, come to my office hour, let's chat. But I'm always thinking to myself, okay, what is the first step? And the first step in these problems are going to find the zeros. Okay, so our function is negative 1/2 x minus 2 squared minus 4 equals 0. So we're just doing what we did before. We're going to subtract things over. We're going to solve for x. And we're just going to find the zeros first. All right. So add 4 over, right? So negative 1/2 x minus 2 squared equals positive 4. And then I'm going to multiply by the reciprocal so that I isolate that squared portion so I can square root both sides. So I'm going to take this. If you don't like those brackets, because I already have the curved brackets, sometimes in math we like to do square brackets so we can differentiate. I can also do them in a different color. I can use green. Okay, so I can write them in square brackets to show that, hey, those square brackets belong together so you don't get confused. Up to you, really. So I'm going to multiply by -2 because 2 is the reciprocal of -1/2, right? So I'm going to multiply this side by -2. And so now I have, is that really what I want to do? I think so. When you take the square root of a negative number, anyway, okay. X minus 2 squared equals -8. Okay, so when we're doing these problems, we have to notice first if the function is negative, which means we know that this parabola is going to point downward. So if it's negative, then we can't use our previous way of finding the zeros to find the zeros. And also with this certain parabola, we have this kind of situation going on where there's actually no zeros of the x. So there's not going to always be these zeros because sometimes the parabola is down here pointing down, below the x-axis pointing down, or above the x-axis pointing up. So there are actually no zeros. So that happens sometimes. So when this happens, we have the vertex form. So this is called the vertex form of a quadratic equation. And that means that we can just look at the equation and then write down the vertex. So y in this case is that f of x. A in this case is that -1/2. X minus h in this case is that 2. Remember, h is +2, not -2, because in our vertex form, we have that negative right there. Okay, squared plus k plus, we have -4. Okay, so that means, so now we can write down all of our things. We need h, so vertex equals h is going to be +2, remember, because we have that negative. Okay, so you got to watch your negatives. And comma k. Now k is negative because it's in our vertex form, it's positive. So it's going to be -4. So our vertex is 2, -4. So I'm going to grab my vertex and graph that really quick. So I have 2 in the x direction, positive direction, but I have 4 in the negative direction. So there's my vertex. So now I'm going to pick a number close to my vertex to graph. So I'm deciding that I'm going to pick 1. 1's a great number to pick. 0's a great number to pick. So you just want to pick a number, and it doesn't really matter what number you pick so long as it's close enough to the vertex that it's going to be on our graph so we can graph it, if that makes sense. If we were writing this down, you could pick whatever number. So I wouldn't pick 15 because 15 is off our graph. So I'm not going to have very much success in graphing x equals 15. Okay, so I'm picking 1. So f of 1 equals, now I'm just going to plug in 1 and see what I get for y. So I have -1/2, and then I'm going to plug in 1 here. 1 minus 2 squared minus 4. Okay, so I have -1/2. 1 minus 2 is -1. -1 squared is +1. So that's just +1, and then -4. So then I have a negative times a positive is a negative. So this is -1/2 minus 4. So is -4 1/2. Or if you want to write it as in decimal form, negative 4.5. I'm wondering if I can graph this. I might need to pick a different number. Let's see, positive 1 and negative 4.5. So it's not letting me graph that. See, so I'm thinking if I choose 0, that might be better. So I'm just going to go ahead and choose 0 and see what happens here. Go ahead and erase some of this stuff right here. Kind of looking for a whole number so that I can graph this thing. Okay, let's choose 0. 0. 0 minus 2 is negative 2. Negative 2 squared is positive 4. Now I can rewrite this 4 as 2 times 2. One of the 2's cancel, and then I have negative 2. Negative 2 minus 4 is negative 6. Okay, that worked really well. I can graph that. So 0, negative 6 is what I'm graphing. That looks good. Let's see if we're correct. Move out of the way here. All right, that worked really well. Okay, same thing with this one. We're going to do our h, k. And I used to be able to go to another board. I'm just going to open another whiteboard. Okay, so I have this. I just want to save this piece. So I'm just going to move to another whiteboard here to write down this equation. Y equals negative 3 times x minus 1 squared plus 1. So what is my h? My h is 1. And what is my k? My k is positive 1. So my vertex is 1, 1. All right, so let's move my vertex to 1, 1. Notice it's negative, so my parabola is going down right here, right? So I'm going to pick a 0, and I'm going to see if it gives me a whole number, right? So that's the name of the game. So y equals negative 3. I'm going to plug in 0, 0, negative 1. Oh, look, there's no fraction, so it's going to give me a whole number. So this is good. 0 minus 1, negative 1. Negative 1 squared is positive 1. Negative 3 times positive 1 plus 1. So remember please excuse my dear Aunt Sally. That's why we did so much work with that, because it now comes in handy. We need to know that information. We always multiply first and then we add. So negative 3 times 1 is negative 3 plus 1 is negative 2. Okay. So now this point is 0, negative 2. 0, negative 2. Okay, let's see if this looks good. All right. These aren't terrible. Oh, look, we've got a fraction again. So we've got to pick a point that makes sense with the fraction so we end up with a whole number, essentially. Might take a few tries. That's okay. So g of x, again, we're calling this graph G. Why are we calling it G? Just for fun. When you get into algebra 2 and pre-calculus, calculus, you'll have multiple graphs on one screen, so it's helpful if you name the graphs to be F, G, H, Now we just are creative and we name them whatever we want. X minus 6 squared plus 1. Okay, so my vertex, I'm just going to write it down, is H, K. My H is 6. My K is 1. So I'm going to go ahead and graph that. 6, 1. Okay. Now I notice that it's positive, so it is going to be like this where it's pointing up. So now I'm just going to plug in a number that's going to make sense. I really think, let's see, if I plug in 0, if I plug in 0, it might give me a value like way up there. It might give me a really big value. Yeah, so 0 is not going to work. So let's pick a different number. I don't know, right? Let's see. Let's pick 5, right? We want to pick a number close to the vertex so that we get a positive number. Okay. This might take a few tries, but I'm going to pick 5 for now. Let's see if 5 works. And when 5 doesn't work, then I can make an educated guess of a different number that's going to give me a whole number. Again, if you were just graphing this on plain graph paper, you would be fine with picking 5. I'm not sure if it's going to give me a whole number. So that's what we're going to figure out here. 5 minus 6 squared plus 1. Okay, I can already see 5 is not going to work because 5 minus 6 is -1. -1 squared is +1. And then I'm going to get a 1/3 plus 1. That's not going to give me a whole number. So that's not going to work. So I think if I pick 3, it's going to work. Okay, so g of 3 equals 1/3 3 minus 6 squared plus 1. Okay, 3 minus 6 is -3. -3 squared happens to be 9. This is going to be a nice number to do. 1/3 times 9 plus 1. So 9 divided by 3 is 3. 3 plus 1 equals 4. So my point here is 3, 4, which is on my graph, and I can graph it. 3, 4. So it's pointing up. That checks out. 3, 4 checks out. Let's see if this works. Yes. So it might take you a few tries to realize, especially when you have those fractions. Okay. No fraction here. That means any point I pick is going to give me a positive number. So super easy. So I don't even have to write down the equation. I can just look at my equation and I can find my vertex. Vertex is h comma k, which is h is going to be +2, and then k is going to be -6. Okay. So I'm going to move my vertex to 2, -6. 2, -6. I notice that it's positive, so it is going to be pointing up. And I'm actually going to choose 0. 0 is usually a nice number to choose. So y equals 4x minus 2 squared minus 6. I'm going to plug in 0. 0 minus 2 squared minus 6. 0 minus 2 is -2. -2 squared is +4. 4 times 4 is 16 minus 6 equals 10. So my point here is 0, 10. Oh, that barely made it. Barely. 0, 10 is, it's not going to work. It's not going to work for me because it won't let me go to 10. The most it'll let me go to is 9. So actually, that's not going to work. That's okay. I make these mistakes so you guys don't have to. I think 1's going to work. Let's do 1. Change to pen. Okay. 1 minus 2 is -1. -1 squared is +1. 4 times +1 is 4 minus 6 is -2. So my point here is 1, -2. Okay, let's graph this. 1, -2. Okay. That looks good. Again, you're going to have to plug in a few points and make sure that it's in your graph so that Khan will let you graph it. that is it for this week. I hope you were able to watch these little watch these videos. These are big videos. Make sure you watch a little bit every day, try some problems, and have that be your math for today, for that day. For this week, usually we students sometimes like to be done in a 4-day week. So you've got 10 squares to do in 4 days. Make sure you spread out your work appropriately, or you can just sit down in one day and do it all. It'll take you a few hours. But I hope you enjoyed my explanations, and I hope these videos help. Thanks, guys. Bye. See you next time.